In this episode, we're going to make sense of what happens when personal information leaves the neat, familiar world of individual systems and enters the world of analytics, data warehouses, and AI, where the whole point is to combine data and discover patterns. That combination is exactly where privacy intent can quietly get lost, even when nobody is trying to do anything wrong. A beginner-friendly way to think about it is that privacy intent is the reason you collected data in the first place, the limits you promised, and the expectations a person would reasonably have about how their information will be used. Analytics and aggregation are powerful because they create new meaning from old data, but they can also create new risk from old permissions. By the end, you should be able to explain why privacy can fail in analytics environments, what good control looks like at a high level, and how to keep the original boundaries of purpose and fairness from dissolving as data gets reused. To control analytics without losing privacy intent, you first need a simple definition of what analytics and aggregation really do to data. Analytics is the practice of examining data to understand what happened, what is happening, or what might happen next, while aggregation is the act of combining multiple records into a summary view, like totals, averages, trends, or group counts. A data warehouse is a central store designed to bring data from many sources together so it can be queried and analyzed consistently, often over long time periods. AI, in a privacy context, often means using models to classify, predict, recommend, or generate outcomes based on patterns learned from data. The privacy twist is that each step you take toward convenience and insight usually increases distance from the original collection context, and distance makes it harder to remember the original limits. When people talk about losing privacy intent, they are describing a gap between what was justified and communicated at collection time and what is later done in analytics because it seems useful. A core reason privacy intent gets lost is purpose drift, which happens when data collected for one reason becomes tempting for another reason once it sits in a central place. Imagine a school collects student contact details to notify families about schedule changes. Then later an analytics team realizes those details could help measure attendance patterns and target interventions. The goal might be positive, but the leap from notifications to profiling behaviors can be bigger than it looks. In a business setting, an app might collect location to provide a feature, and later a warehouse team wants to use location history to build marketing segments. Beginners often assume the biggest privacy risk comes from hackers, but in analytics the most common risk is internal reuse that slowly expands beyond the original intent. The control challenge is not to stop analysis entirely, but to force every new use to pass through the same kinds of checks that existed at the beginning, instead of assuming central storage automatically makes reuse acceptable. Another reason is that aggregation feels like a privacy cure, but it can be misleading if you do not understand re-identification risk. Aggregated reports can reduce exposure because they remove direct identifiers like names or emails, yet aggregation can still leak information when groups are small or when multiple reports can be combined. If you publish a report that shows a statistic about a tiny subgroup, someone might infer who the data describes even without seeing a name. Even inside an organization, an analyst might join an aggregated table with another dataset and unintentionally reconstruct individual-level insight. This is why privacy controls cannot rely only on the idea that summaries are always safe. You need rules about minimum group sizes, suppression of small counts, and careful review of how outputs might be combined. The privacy intent here is to allow learning at a population level while preventing the analytics process from turning into a backdoor to individual surveillance. Data warehouses introduce a different privacy risk. They encourage copying, standardizing, and keeping data for longer than necessary because storage seems cheap and centralization seems efficient. Once data lands in a warehouse, it often gets transformed into formats optimized for querying, and those transforms can strip away important context, like why the data was collected, what consent was given, and what restrictions apply. If the warehouse does not carry that context forward, downstream users may treat the data as a generic asset rather than information tied to real people with expectations. Another subtle risk is that warehouses frequently feed many consumers, like dashboards, reporting jobs, and AI pipelines, which multiplies the number of places privacy intent must be enforced. Beginners sometimes picture a warehouse as one locked room, but it is more like a busy library where many people can read the same book. Control means you need guardrails that follow the data, not just a strong lock on the building. A helpful mental model for beginners is to separate privacy controls into 3 layers: controls on data going in, controls on data at rest, and controls on data coming out. Data going in is about deciding what is allowed to enter analytics systems and under what conditions, including whether data must be reduced, masked, or separated before ingestion. Data at rest is about how the warehouse stores and organizes information, including access control, segmentation, and retention behaviors. Data coming out is about how queries, dashboards, exports, and model outputs are governed so sensitive insights are not exposed to the wrong people or used for the wrong purpose. If you only focus on one layer, the other layers will become the weak point. For example, you can restrict access to the warehouse, but if data going in is over-collected or the outputs are exported freely, privacy intent will still be lost. A complete control approach treats analytics as a pipeline with checkpoints, not a single system with a password. One of the most practical controls to preserve privacy intent is strong data classification combined with clear labeling of allowed uses, because classification tells people what the data is and the labels tell people what they may do with it. Classification can be as simple as identifying whether a dataset contains personal information, sensitive personal information, or non-personal information, but it must be consistent and understood. The allowed use label is where privacy intent becomes operational, because it connects the dataset to purpose, consent constraints, and legal or policy requirements. If you cannot tell, at a glance, whether a dataset may be used for personalization, fraud prevention, product improvement, or research, you will end up with analysts guessing. Guessing is how privacy intent disappears. This is also where beginner misunderstandings show up, such as assuming that removing a name means the dataset is no longer personal, or assuming that internal use is automatically permitted. Control should make the right action easy and the wrong action obvious. Access control in analytics environments needs to be more thoughtful than simply giving or denying access to a whole database, because privacy risk is often tied to columns, joins, and query patterns. A data analyst might need access to purchase totals, but not full addresses, or they might need access to records for a region, but not global records. In technical terms, this is about enforcing least privilege in a way that matches how analytics actually works, and it can include column-level restriction, row-level restriction, and separation of duties between roles. Even without getting tool-specific, the concept is that the warehouse should not treat every user as equally trusted just because they are inside the company. It should provide the minimum views needed for the job and prevent casual browsing of sensitive attributes. A beginner-friendly analogy is a school office that lets staff view student attendance for their class, but does not let everyone view disciplinary records for the entire school. Privacy intent is protected when access matches need, not curiosity. A major issue with analytics is that copying becomes frictionless, and frictionless copying spreads risk. People export data to spreadsheets, send extracts to teammates, or move data to separate environments for experimentation, and those copies often lose controls. This is why governance must address data movement, not just data storage. A sound control approach includes rules for when data can be extracted, what format it must be in, how long the extract may exist, and how it must be protected. It also includes accountability, meaning you can trace who pulled what, when, and for what purpose. Beginners sometimes think governance is paperwork, but in analytics, it is the difference between data staying within a controlled environment and data becoming unmanaged files scattered across laptops and shared folders. When data moves, privacy intent must travel with it, or it will be replaced by convenience-driven decisions. When AI enters the picture, privacy intent faces new pressures because models can learn and reproduce patterns that feel like new information, even when trained on ordinary data. A model might infer sensitive traits from seemingly harmless signals, such as predicting health-related conditions from purchasing patterns or predicting location routines from app usage. This matters because privacy controls that focus only on direct identifiers will miss the deeper risk of inference. Another pressure is memorization, where a model trained on detailed personal records can sometimes reproduce specific details, especially if training data is not carefully managed. A beginner does not need to know the mathematics of machine learning to understand the risk. If you feed a system detailed stories about people, it may later reveal details in ways you did not expect. Preserving privacy intent in AI means setting boundaries on what data may be used for training, what outcomes are acceptable, and how outputs are reviewed for unintended disclosure. Data minimization and privacy-aware feature selection become especially important for AI because more data is not always better when the goal is responsible outcomes. Beginners often assume that accuracy always improves with more personal data, but in many cases you can get useful performance using less sensitive signals or by reducing granularity. For example, you might use age ranges instead of exact birth dates or regional indicators instead of exact addresses, depending on the task. You might also avoid collecting or using attributes that are not necessary for the model's purpose, because unnecessary attributes increase the chance of unfairness, bias, or privacy harm. The privacy intent is reinforced when the training dataset aligns tightly with the purpose, rather than becoming a grab bag of everything available. This is also where privacy review should happen before model training starts, because once a model is trained, it can be hard to prove what it did or did not learn from specific attributes. Thoughtful limits up front are often more effective than fixes after the fact. Monitoring and auditing are not optional in analytics environments because the most damaging failures can be quiet, gradual, and hard to spot without visibility. You need to know what data sets are being accessed, which queries are being run, and whether unusual patterns suggest misuse or overreach. Auditing also supports governance by showing whether controls are actually followed in practice, rather than existing only in policy documents. A beginner might hear the word audit and think of punishment, but in privacy engineering it is often about learning and improvement, such as discovering that a dataset is frequently exported and deciding to provide a safer internal view instead. Another reason auditing matters is incident response, because if data is misused or exposed, you need a clear record of what happened and what was affected. Privacy intent is protected when you can detect drift early and correct it before it becomes normalized behavior. Without monitoring, analytics systems become a place where small shortcuts accumulate until the original boundaries are unrecognizable. It also helps to understand that privacy controls must apply to outputs, not just inputs, because dashboards, reports, and model predictions can reveal personal information even when the underlying data is protected. A dashboard might display information at a level of detail that exposes a specific individual, such as showing metrics for a tiny team or a rare combination of attributes. A model output might enable tracking, like a stable identifier that allows a person to be followed across contexts, even if their name is never shown. Controls on outputs include reviewing what is published, enforcing minimum aggregation thresholds, limiting who can view sensitive dashboards, and ensuring that decision-making based on analytics follows fairness and necessity principles. For beginners, the key is to see analytics outputs as a form of data sharing, even when it stays inside the organization. Sharing has consequences, and it needs safeguards. If you treat outputs as harmless because they are only numbers or scores, you will miss the ways those numbers can affect real people. A common misconception is that anonymization automatically solves privacy issues in analytics and AI, but true anonymization is difficult, and many datasets are better described as pseudonymous, meaning identifiers are replaced, but the data can still be linked back with additional information. Even when direct identifiers are removed, a combination of attributes can act like a fingerprint, especially when datasets are rich and cover long time spans. This matters for warehouses because they are designed to be rich and long-lived, which increases the chance that someone can connect the dots. The honest control approach is to treat de-identified data as still potentially personal unless you have strong reasons to believe re-identification is not reasonably likely. That mindset drives more careful access control, better output restrictions, and more cautious sharing practices. For beginners, it is useful to remember that privacy risk is not only about names, but about uniqueness and linkability. When data makes someone stand out, it can become personal again. As you bring all of this together, the big goal is to preserve privacy intent by keeping purpose, limits, and accountability attached to data as it moves through analytics, warehousing, and AI. That means recognizing where intent tends to drift, like centralization, copying, and inference, and then putting controls at each stage of the pipeline so privacy is not left to memory or goodwill. It also means treating analytics as a powerful capability that must be guided, not a free-for-all simply because it is internal. When you can explain how classification, access boundaries, controlled movement, output safeguards, and auditing work together, you are thinking like a privacy engineer, not just a data user. In real organizations, these controls help teams get value from data while staying aligned with obligations and expectations, which is exactly what a privacy program should achieve. The most important lesson is that privacy intent is not a slogan that survives on its own. It has to be built into how analytics systems operate so that insight does not come at the cost of trust.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.